This is Thanksgiving practice number 3. There are 3 blocks, A, B, and C, that are stacked and not moving. The masses of the blocks are 3 kilograms, 3.5 kilograms, 4.5 kilograms. So what we're going to do is turn these masses into forces. And remember that F of G is equal to mass times the gravitational strength, and for this class we're going to be using about G is going to equal about 10 newtons per kilogram. So this is going to be about 30 newtons, 35 newtons, and 45 newtons. Okay. So for A, I'm going to do A in blue. A is interacting with B. A is interacting with the earth. There are no other interactions with A because that's all it's touching. So now B is interacting with C. B is also interacting with A, and B is interacting with the earth. Okay. Next, we are going to do C. C is interacting with B, but C is also interacting with the floor, and C is interacting with the earth. Okay, and there's our earth. Okay, so now we are going to look at the velocity, or the position. The blocks are at rest. They are not moving. There's no speed on the blocks. There's no velocity on the blocks. So we are going to look at this graph. At 0 seconds, 1, 2, 3, and 4, there is 0 velocity occurring. So here's 1, 2, 3, 4, and 0 velocity. So we're going to just draw it right here at 0 meters per second. Okay. Because there is no velocity, that means the position is going to remain the same. So it's going to stay at 4 meters. That means that for our position time graph, it's going to stay at 4 meters. Now, what does that mean for the motion map? Well, here's 1 meter, 2, 3, and 4 meters. It's just going to stay here for 4 seconds. 2, 3, so time is equal to 0, 1, 2, 3, and time is equal to 4. Okay, now we're going to go to this question. What is the block B's mass on the moon? Now, from our previous information, mass of block B is equal to 35 newtons, or sorry, 3.5 kilograms. The block's mass will be the same on the moon because mass does not change. Okay, now let's go do the force diagram for A. So A is at the very top. That means that the force of gravity is acting upon A, and it is acting on A at 30 newtons. It is also being pushed up by B at also 30 newtons. Okay, and that is it. For block B, block B is being pulled down by gravity, or gravity's pull. Earth is causing the force of gravity on block B, and that is happening at 35 newtons. And also block A is pushing down, block A is pushing down on B at 30 newtons. This means that C, which is holding up both A and B, is pushing on B by C at 35 plus 30, which is 65 newtons. And now block C, block C is being pulled down by gravity, or Earth is pulling down block C using the force of gravity at 45 newtons. Block B, which now also bears the weight of A, so block B is pushing down C at 65 newtons. That means the floor is holding up A, B, and C, so 45 plus 65 is going to be 110 newtons. Okay, and then if all three blocks were dropped from the same height at the same time, which would hit the ground first? Actually, we haven't talked about this, so we'll talk about that another time. Which block weighs more? Block C, because of its mass of 4.5 kilograms, results in a weight of 45 newtons. And that's because F of G is equal to M times G. 45 is larger than 35 and 30. So this is from B, this is from A, and this is block C. All right, thank you.